Hello, everybody. I'm Everton de Oliveira from the Groundwater Project, and today we're here to show you this very nice book that's released by our project, and it's already free for you to download on our website. The website is right down here. You can just click on it and go for this nice book. And we have the pleasure to bring to you Dr. William W. Woessner. His a www before the www exists, right, Bill?
That's right.
He is an emeritus professor of hydrogeology at the University of Montana, United States, with more than 40 years of experience and 60 plus mentored graduate students, among many other important achievements. I invite you to download the book again and check. You have his CV there, and the book is very nice. Nice illustrations, well explained. I love it. And it would be very helpful when I was a young hydrogeologist if I had that book in my hands. I'll tell you some of the stories, and Bill would illustrate you why that would be important. So nice to meet you again, Bill. Please welcome. Say hi to our audience, please.
Yeah, nice to be here, and I hope the book will be used and we'll get good feedback.
Oh, certainly will, certainly will. Please, the book is about groundwater and surface water exchange. This is quite interesting. Surface water is usually taught for engineering schools, and groundwater for earth science. Are they so far apart as they seem by how they are usually taught in schools?
Well, I think your observation is a good one. You know, the concept that sort of hydrology in the big term was really related to surface water and was sort of owned by the engineering world, and then groundwater was more of a science that was owned by the geological sort of portion of the world. But in reality, as far as groundwater-surface water exchange, I mean, one main point of the book, and has also been echoed by numbers of other authors, is that they're really a single resource. That when you think about how you see water on the surface, the next thing you should think about is that, well, how is groundwater interacting or interfacing with this surface water feature, or vice versa? If there's a surface water feature, a river, a stream, a lake, how is it exchanging water, or is it exchanging water with the groundwater system? So I think that you're correct, that in the past, there's been separate textbooks written about the issues. Hydrology is often, again, captured by the engineers, which focus on the surface water aspects, runoff and rainfall and forecasting, how much flooding, those kinds of things. And the groundwater portion is most often been associated with thinking about, well, what about the water underground? What about a resource for a well field? How can we generate water to supply humankind?
Yes, that's true. That's true. Well, yeah, this is quite an interesting topic, and more than that, it's a very important topic. Could you summarize the relationship between groundwater and surface water to a person that is not from the field? Because when we talk, we have the jargon and we have all the experience in our lives, and we tend to think that people know that. Could you try to summarize and explain for someone who's interested in starting the career, please?
Well, I think one of the easiest examples is when you're talking with folks, you say, well, you know, do you have any rivers or streams in the area where you live? And usually the answer is yes. And you say, well, tell me about them. Is there water in the stream all year round, or is there water in the stream only part of the year? And then you start to have a discussion about, well, why do you think that is? And the interesting example is here I live in Montana, and we have a number of rivers that come out of the mountains and flow into the valleys, and they flow all year round. So the question is, when it's minus 30 centigrade and it's snow and ice everywhere, why is there water still in the rivers? And the answer is that that's groundwater coming out of those big basins that was put in during recharge periods and is now discharging to the rivers and maintaining the flow during the winter time. And in other climates where things are reversed, or in other parts of the world where things are reversed, you would see a similar type of response. So I think that's the easiest way to start to think about it. Like, oh, well, you know, why it's not raining all the time, at least in some climates. And so those surface water features are maintained with a water balance. Water has to go in and water has to go out. And the question is some of that water going in or some of that water going out also groundwater coming from the subsurface, not just coming from rainfall and runoff kinds of things. And then some of those features also recharge the groundwater systems at either all the time or part of the year. And so that's another way to think about it. Well, what's happening to the groundwater system beneath these lake systems, for example, or wetlands? So I think that it's, when you think about they're basically two dependent systems, and they interact a lot. They interact all the time. And there are always exceptions, but more generally, the concept is that there is an exchange process going on from one of the systems, the underground system, to the surface water system, or the surface water system losing water to the groundwater system.
Yes, that's correct. You had a very nice example. This comes to mind all the time when you think about surface water. Always rivers come to mind. But there are, like you mentioned, there are other important surface water bodies. And what would be the relationship, and how would they differ from rivers? Could you tell us something about that? Is that something explained in the book?
Right. And as the book was prepared, the concept from the Groundwater Project was to try to present a number of conceptual sort of diagrams and map views, cross sections and map views that made the concepts sort of easily illustrated to and easily seen by those looking at the illustrations. So I would say that the relationships are for the three things that I discuss in the book: rivers, lakes, and wetlands, that the exchange processes are all very similar. They're all the same, but they're just happening to different features on the surface. And so we have a system where we have groundwater that wants to exchange flow into these surface water features. And in groundwater terms, we would refer to them as an effluent situation. Groundwater is discharging, becoming effluent to the surface water feature. And then we have a system where, a situation where the surface water provides recharge or water to the groundwater system. So it's the same thing, whether it's a lake, whether it's a river, or whether it's a wetland. These exchange processes can occur in all of those different features. And so if you understand the basic principles of this exchange process, then if you're going out in the field and trying to investigate, well, here's a lake sitting here, how does it fit into the groundwater system? You can then decide how you might set out instruments and do studies to actually quantify where and when and how water is exchanging between those features. So conceptually, the idea is water goes from the groundwater to a surface water feature, from the surface water feature to the groundwater feature, or maybe groundwater flows in one side of the surface water feature and flows out of the other side. Or it could be a situation where there's some mixed things going on. Groundwater's coming in some places, and then in the bottom of a lake, some lake water is seeping into the groundwater. We sort of refer to that as a mixed condition because it's not just one or the other of water flowing in or water flowing out.
Oh, that's very nice. Well, but are those similarities, they hold as well for chemical properties, or this is mostly physical conditions that are similar for lakes?
Well, the chemistry is used to look at some of these exchange processes to look for changes that would be occurring in the surface water or in the groundwater as a response of how water is moving between the two systems. So very often when we look at the quality of a stream, we may find that it has a signature of the groundwater that is interacting with that stream, as well as the signature of the water the chemistry of the water that's being generated on the surface. And we can use numbers of geochemical tools to help us understand how this exchange process takes place, from using water budgets and chemical budgets of lakes to understand how much water is coming in from one source versus another source.
Oh, that's very nice. Is it difficult to measure the flow between groundwater and surface water? Is it expensive? Are those techniques part of your book?
Yeah, I mean, the book was organized that the first 4 chapters were really talking about the conceptualization of how groundwater moves and exchanges between lakes, rivers, and wetlands. And then the 5th chapter really is all on methods. So it has extensive references and diagrams, and talks about, well, how do you actually implement quantitatively or qualitatively figuring out how groundwater and surface water are exchanging in these surface water features. And the answer of whether it's expensive or can be done with lower cost is a function of scale and a function of what the purpose or what question you're really trying to answer, right? I mean, you can be as simple as taking a thermometer and going down a stream, small stream, and poking it in the bottom of the stream and measuring the temperature of the water in the bed and comparing it with the temperature of the groundwater and the temperature of the stream water, putting in small little coin-size instruments that would record over time changes in things like temperature or conductivity of the water, to doing more extensive studies where you set up permanent surface water gauging stations and you're measuring flows in the river, or you're doing chemical tracer tests in the river, or you're flying remote sensing and looking at temperature changes using aircraft or drones to figure out what's going on.
Oh, that's quite interesting. I've seen some, one of the illustrations show you installing optic fibers to measure temperatures. How would that be?
Right, so the technology is out there. It's used for many different things, but you basically take a fiber optic cable with sensors in it that you lay down on a stream bottom, so it's in good contact with the bottom, and then you're able to send signals back and forth up and down that wire, and every meter or so you can get a reading on what the temperature is at that location in the bottom of that feature, and you can lay it out lengthwise for kilometers down a stream to examine where this exchange process might be happening. Or you can take it and basically weave it back and forth over an area so that you can do more of an aerial study of a section of a stream or a lake or a wetland.
Well, that doesn't look that expensive to me, is it? Because you can have lots of measurements from a single wire, right?
Yeah, well, the best thing to do is to borrow it from somebody who already has one, because the instrument to send the signals and then read and interpret the signals is quite expensive. The cable itself may not be that expensive, but the whole setup can be quite costly. But the best thing to do is to look around and find who might be doing this research and who might have purchased such equipment, and see whether you can either have it loaned to you or you can rent it instead of buying it. And I'm not an expert on that particular aspect of temperature monitoring, but it's used quite often to especially look at river systems.
Yeah, well, it's using down the hole as well for wells.
Oh, it can also be used vertically too, right? In a borehole to do vertical temperature monitoring. That's another application of it. I mean, it kind of would relate to the surface water groundwater exchange, but it's all used in many other aspects of groundwater science too.
Another method that is quite common, and I remember I used here in Brazil a long time ago for the first time. That was the seepage method that you can do it at home, right? You can use like a drum and prepare it yourself. That is quite inexpensive. You need some care to do it properly, but it can be done, right?
Absolutely, and this is it's one of the only methods that's out there where you actually measure a rate of movement of water between the bottom sediments and the surface water groundwater system. So it directly measures that, and it's conceptually it's a 5-gallon bucket or a 208 liter drum top, like a barrel, an oil barrel drum.
Like a oil barrel, yeah.
Cut it off, and you jam it down into the sediments. Put on a plastic bag so you can collect the water coming out of it, and it basically gives you an idea of what the rate of water is coming through that area over, again, a rate over a period of time. Or you can fill the bag up and let it go the other direction and see whether it's seeping water into the system. So like you, I first started my sort of investigations in surface water, groundwater exchange, looking and learning about seepage meters, and I put them in Lake Mead, Nevada in the USA, trying to figure out in some of the shallow bays what the groundwater exchange process was in those systems. And again, it was relatively inexpensive. For classes, I've used buckets, just cut off, even plastic buckets that you fit with a stopper and some tubing and some bags to demonstrate how you can measure this flux.
Yeah, that's quite interesting, and it's very effective. I used it many times, and it's quite effective. You are correct. Since you have many experiences in the field, as your pictures and situations show in the book, what are the most striking situations you have witnessed in the field that you could mention to us? What are the ones that are difficult to figure out?
Well, I think that and we were discussing prior to sort of getting started on this interview, having your own conceptual models of how you think things work. So you can think, well, a stream is always receiving groundwater discharge. So if I go study a stream, I should think about how much groundwater is getting into that stream, and I should put wells in near the stream, and I should measure flow rates and do various things. But that conceptual model may not be correct, because you go into an area that you have this idea of how you think it works, but when you actually go out and instrument the stream, you find out, no, it doesn't work like that at all. I live in an area where we have a stream that flows, maybe 50 cubic meters per second. It's a big gravel bedded river. It goes right through the middle of town. And I looked at it and thought, it's a regional groundwater discharge area. The groundwater must be coming from the mountains around where I live and discharging to this section of river. Though when I actually started looking at the data and started drilling some wells, I found out the river was 30 feet, in this case, 10 meters above the water table. That in the section of river that as it came into the valley, it was permeable enough that the water table was lower than the actual river level. And so I think that's something that you go in with a conceptual model of how you think something might work. And I think what the book is trying to do is saying, well, it's not just one conceptual model. There are 3 or 4 conceptual models of how the river, stream, lake, or wetland might actually interact with the groundwater system. So you need to consider all of those and not just a conceptual model when you first start to look at a situation in the field. So I think that's kind of been exciting. The other thing that I was fortunate enough to get engaged with was some of these river ecologists, people who work on rivers and the biology of rivers and fish and macroinvertebrates. And we have some pretty strange situations where they were pumping wells near rivers and 5-centimeter long invertebrates were coming out of the wells. And so this was like, well, how's this work? And it was a situation where the permeable material of the lake, permeable material of the floodplain was allowing these insects to move from the river through the gravels to the wells, which is very, very unusual. But it was, again, a conceptual model that I never would have anticipated that there would be anything like that would be going on, and that the ease at which water could move through these coarse-grained gravel systems was just amazing. It was a tremendously high hydraulic conductivities to allow these kinds of creatures to move around. So exactly. Unique, but fascinating,
Exactly. Because we tend to believe that all permeable materials are filters, right?
Exactly. But when you have a big bar system in these big gravel bedded rivers, you end up with gravel that has no matrix in between it. And so it's called open framework gravels. And then you can have rapid movement of water and of other things through those sections of the aquifer. So it's absolutely fascinating. Geochemically, it's interesting. And this is all hyporeic water, which is another subject that we talk about in the book. In the river system, it's the exchange of river water into the groundwater system. And then the water in the groundwater system comes back to the river again. And so it's this sort of movement of water from the river into the groundwater system and back into the river again. And it happens at multiple scales, along floodplains, in and out of the riverbed and banks, and even within bars and dunes on the bottom of the river channel itself. So I don't know, it's just fascinating as far as it goes, and it expands.
I love it too. Well, but I have a question, a specific question. How would they guess the insects coming into the well? Was it a monitoring well, or was it like a dug well? Because that's quite unusual. That's quite unusual.
Well, we shouldn't get too far down that rabbit hole, so to speak. But it's actually, again, it's a very unique geological setting of these very high hydraulic conductivities, and they were coming out. They were first noticed coming out of domestic wells, drilled 10 to 40 meters deep near these big rivers. And then they started putting in monitoring wells with big slots so that you could allow insects to get into them. And they would actually do that. And I call them insects. They're actually macroinvertebrates, and it's the larvae that are crawling around in the system. And this is work of Jack Stanford and the Montana Biological Station, Flathead Biological Station. So it's a fascinating area.
Definitely very interesting.
But it's unique. So don't get too excited. I mean, this is a unique area.
Well, it's good that it's not common, right? After all.
Yes, exactly. But it's one of the things that sparked my interest in surface water groundwater interaction, like how, especially in big river systems.
Well, I have a question for you, because I checked the book and I've read that. Would I be able to study it by myself using the book? Like reading, do I need a tutor, or I can survive if I can read it all and go through the exercise? What do you think?
I think you could do it as a self-study. Certainly, you could do that, because not only do it, I try to be pretty straightforward in the conceptual models and trying to easily explain the concepts. And then in the methods section, you can take as much or as little of that as you would like, depending on what your interests are. I tried to put boxes in that were examples that would sort of illustrate some of the methodologies or some of the concepts that I was trying to get across. And then there's exercises at the end with solutions. So you could work the exercises and then also look at the solutions. So I hope it could be useful as a self-study type of text, as well as could be used in courses on surface water groundwater interaction in schools at multiple levels.
I do hope so. I believe it'll happen, because I've read through the book, and I think it's well explained and easy to go on your own. So I recommend for young students to go through that, because this is quite interesting and it's very useful on your career. I have one question. When I was leaving my PhD, that was long ago, well, I don't know, 20 years, more than 20 years ago, we had some troubles, groundwater and surface water modeling. We had a problem because groundwater usually is very slow, and compared to the velocity of the surface water, and it was hard to match the models. How is it today? Because I know today we have very good models that do that for us. What can you say about that to us?
Well, it's an interesting challenge, and in the book that I've prepared, I really don't talk about that specifically. I mention references where people can go to find out more information about that. So it doesn't deal with that type of modeling, which is, trying to link both a surface water, groundwater model, or do some combined groundwater surface water modeling. And there are challenges, just as you've stated, where you have time scales which are very different. So groundwater might move a meter in a year, and surface water moves a meter in half a second. So when that's happening and you're trying to capture all of that action, then you need tools, mathematical tools, which will allow you to average and exchange and figure out how to move water between those two systems in a realistic way. And that's the hard part. But as you said, there are more tools available today than that will help you do that. Usually it's pretty heavy duty computer processing is needed to make that work too. And my book doesn't really address those kinds of issues, but it's more practical in the sense of how does groundwater surface water exchange occur in these systems, and what are some of the simple methods that can be used to help identify where this happens and to quantify how much exchange is happening.
So, Bill, you have a very long and productive career, as your CV shows. Would you recommend groundwater for young students?
Oh, absolutely. We can't live without it. So that's something that you should keep in mind as far as looking at a career opportunity to get into the groundwater business or groundwater educational realm. It's very worthwhile and it's very needed. I mean, that's part of what the Groundwater Project is all about, is the idea that groundwater is really underpinning the whole water cycle, and the global water crises which are occurring now and will continue are going to be partly, involving groundwater, as well as the impacts of climate change are going to affect groundwater systems too. And what my book is doing is trying to demonstrate the link between groundwater and surface water. So as we see changes in the surface water features, we're going to see changes in the groundwater system too. So yes, it's something that is needed, and it's something that is useful, and it's something that will be of continuing value over time. So I think it's an important field to be in right now. It's a good time to be in the groundwater field.
And it's fun.
And it's fun, yeah. I love to be out. I mean, the subject of this book is groundwater surface water exchange, and I love to be out on the rivers and in the lakes and in the wetlands and looking at everything from the ecology to the exchange process to the geochemistry. So it's a great subject area to concentrate on.
Yeah, and I believe your book shows that, because you see all the work, outdoors, and you have people in the rivers, and you have the students, and you have some experiments there. It was very, very nice. And I think people feel that from the book, that it is fun working with that subject.
And it's easy to teach too, because of the simple methods that are out there to take students out and demonstrate some of these tools is really pretty straightforward. And all you need is access to a section of stream or shore of a lake or some wetland areas, and you can demonstrate a lot of the methodologies. So it makes it good for teaching aspects too.
Thank you. Well, it was very nice talking to you. Do you have some final remarks to say to the people that are downloading the book? What do you recommend, please?
Well, be very interested to see how it's used, and to hopefully get some feedback on how it was put together and whether it covered the subjects that were of interest to people. I would note that I made an effort to include a number of references that are general references that are accessible, free on the internet. A lot of them are United States Geological Survey reports or general discussions of this subject. So there are a number of references that are in the report that are accessible and from the web, and that's, I hope, will be useful to students and to people trying to find out more detail as they look over that over this book. So once again, I always try to plug the groundwater project as a great effort, and that it's something that takes a lot of work and it takes a lot of volunteer hours. So we hope that people will look at the books that are being produced and will be saying, I want to participate. How can I participate? And that we get an even larger number of groundwater scientists involved in producing material without cost for the public use and for educational use throughout the world.
Thank you, thank you. Just to remind you that are watching this, if you like the subject and if you're willing to translate into your home language, please feel free to do so, because you won't have to pay anything for the rights to Bill Woessner. You just have to publish on our website, and that's all. It's going to be very useful for your country and for young students that do not have the complete domain of the English language. Okay, so feel free to contact us to have this wonderful book translated into your language, please. Thank you, Bill. That was
okay. Great. It's nice to talk with you.
It's a great book, and I'm sure it's going to be a huge success. Thank you very much.
All right. Have a great day.
You too. Bye.